Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so without wasting much time, we will be quickly moving on to our video. So in the previous class, we have been talking about household circuits, isn't it? So I think you have understood from the previous lecture that how power is being generated in the far away power stations and then it is being transmitted to the households, isn't it? The light that you switch on or the fan that you switch on, instantly you get, when you switch on the fan, instantly the fan starts moving and you get cold air. You switch on the lights and instantly you get light. So this is all possible due to the electrical energy. Now this electrical energy, you have I think understood how it is being produced and how it is being transferred to our house. So today we will be talking about that how this power that has been transferred to our house is being distributed in our house. Okay, so we will be little bit talking about the wiring system in our house. What is the purpose of the main switch? Okay, then what is the purpose of the fuse? Why there are 3 pins? Have you wondered why there are 3 pins in some of the plugs that you use in some appliances? We will be discussing all these things today. Okay. So coming on to the topic, let us see. So first of all, we have seen that the power is being transferred from the transformer in your locality to your house via the main switch. The main point of entry of the wires is the main switch, isn't it? So there is a meter box present in your house at the front at the just beginning, and there is a main switch connected to it. The meter box, the meter in it keeps on recording the amount of energy that you are consuming, and the main switch acts as a switch by which you can either switch on or off the power coming to your house, isn't it? Okay. So first of all, let us discuss a little bit about the main switch. Okay, so all of you have seen that there is a main switch in your house. I think by now you all know what is the function of a switch. Switch, what does it do? A switch actually turns off or turns on a circuit. You know that current cannot flow in a circuit if there is a break in between. Now this switch, I am just briefly recapitulating. Say consider this is a electrical appliance, say a bulb or a tube like this. Okay, here is a power supply. The power supply may be AC or DC. I am just considering it an AC power supply. Okay, and then there is a switch that will help you to on or off the device, isn't it? So this is the switch. Now see, what is the function? What function does the switch do? This is the AC source, okay, AC source, and this is say a light. A very simple circuit. Now you know what is a circuit? The path through which a current flows can be described as a circuit. This is a very simple circuit. A DC source has been used. There is a switch. There is a light. Now see, when you do not want the light to glow, that is, you don't want the light to function. What you do, you put off the switch, that is, you open the circuit. Isn't it? This is open condition. See, there is a break in between. So the current under this condition does not flow. Okay. Whenever you want to make the light glow, what you do? You put the switch in this condition. You put the switch in the on condition. That is, the switch will look something like this. When you put the switch in the on condition, it looks something like this. This is the switch. Now this is the closed switch. Okay, this is the closed switch. Now see, the gap that there was in between has been closed, and the circuit now becomes a closed circuit. As a result, the current can flow from the AC source through the light and come back to the AC source, isn't it? So in this way, an electrical appliance can be operated from a power source. Now I want to discuss one thing here. See, I can say that there are 2 wires that are connecting the AC source, or it may be a DC source also, to the electrical appliance. One wire is this. One wire is this, that is being taking the current from the AC source, or say it may be a DC source also, from the source to the light. This wire, remember, is called the live wire, that takes the current from the source to the appliance, and the current then again needs to return back so that it forms a complete path so that the current of the electrons can flow. Now this wire that takes the current back from the appliance to the source is called the neutral wire. Okay, so these are the two types of wires that we will be coming across while we will be discussing about the household wiring. Okay, so I am just briefly introducing you to the concept of the live wire and neutral wire. Live wire carries the current from the source to the light, whereas the neutral wire carries back the current from the electrical appliance, here this light, to the source. Fine. Now, what is the main switch? So we are discussing about the main switch from when it was important for you to understand the concept of switch. I have also discussed about the concept of live wire and neutral wire. Now, coming to the point, main switch. Okay, so the main switch, what it actually does is it can switch on or off the power supply to your entire house. You have seen in the diagram that the switch helps to either join the circuit or disconnect the circuit. So that the power that is being coming from the transformer in locality passes to the main switch and enters in your house. So if you want, you can just turn the main switch off. Okay, if you turn off the main switch, what happens? The power to the entire house or the total circuits, they are being turned off. Okay, so the light, all the appliances in your home stops working if you turn off the main switch, stops working. Okay, and if you turn on the main switch, what happens? All the appliances work. All the appliances can work. Okay, clear? So this is the main function of the switch. So you have seen now. Okay, so this is the main function of the switch. The main switch is the, you can say it's a barrier to your house which either allows or stops the entry of the power into your house. Okay, fine. Now let us move on to the next topic, house wiring. Okay, so let us move on to the next topic, house wiring. Okay. Now in the previous chapter, while discussing about current electricity, we have said that there are two ways in which you can connect the resistance. Okay, there are two ways in which you can connect the resistance. Okay, so what are the two types? What are the two ways? One was the series connection and another was the parallel connection. And there was a third type also, mixed connection, where series and parallel are both used. Okay, so if you remember, just connection of resistance can be done in three ways mainly. Okay, one is the series connection, one is the parallel connection, and another was the mixed connection, where series and parallel both are used together. Okay, so see what are actually these resistance? Can you just imagine what are these resistance? These resistance are nothing but actually the resistance actually can represent the various electrical appliances that you are using in your house. Okay, say the tube light, the fan, the heater, the computers or laptops that are using, every electrical appliance has a certain resistance of its own, and that resistance actually can be represented by this symbolic way. This is the representation of a resistance, isn't it? So we have learned this thing these things in current electricity chapter. Now, so the resistances can be connected in series, parallel and mixed connection. If you just think of the series connection, I think you have all remembered. If you have not remembered, please go back to the lecture, type current electricity, okay, future endeavors, and you will be able to see the videos posted on the topic of current electricity. So if you just do not remember, see the videos, you will understand it. Okay. So in series connection, I have said that the major problem was that if I just put off the switch, all the resistance would stop working, because in series connection there is only one path for the current to flow. If you switch off or make the circuit open, the current stops flowing and all the resistance stops working. That is the main disadvantage. So have you noticed in your house that if you want, you can individually operate the fan, the light, or any other appliance? It does it works like this, that if you just switch off the fan, the light also switched off? No, it doesn't happen so. All the appliances are working individually. So how it is possible for to achieve this functionality? By connecting all the appliances in parallel. Okay, so what we do in our house or in practical purposes, mainly the appliances are connected in parallel. So how it is helpful? You can operate the appliances individually. You do not need to switch off or switch on all the appliances altogether. You can individually switch on or switch off the appliances. So in our house wiring, the wiring that are being done in our houses are mainly parallel wiring. Okay, are mainly parallel wiring system. So I think the advantage of the parallel wiring system is clear. Okay. Now there is another term that you will be seeing in the book, that the house wiring is in the form of a ring. What does this mean? See, if we consider the ring system, what does it say? Say this is our main AC source. Okay, this is our main AC source. From this this is the live wire. It goes like this throughout all the rooms in our house, and then it comes back like this. Okay. Now in between, say there are 2 floors in our houses, and each floor has say 3 rooms. Okay. So I can from this part I can take out the 3 connections like this. Say this is your floor 1, connection to floor 1. Okay, connection to floor 1. Now here there are 3 rooms. Okay, so what I can do, I can connect the 3 rooms in parallel. How can I do it in parallel? See, from this wiring you can see. So how can we connect in parallel? So I think you have all remembered the parallel connection. So this is in this way parallel connection was done. Okay, so just compare this connection with these 3 connections, these 3 wires, these 3 wire resistance at the 3 rooms in your first floor. Okay, so it will be something like this. So it is again divided. One wire goes into the first room, the other wire goes in the second room, and the other wire goes into third room. Okay, now all these 3 wires are again connected back to this circuit, main circuit. Okay, so these 3 wires represent 3 connection to your 3 rooms. So say there is one light in your each room. So this is one light in the first room, this is the second light this is the light in the second room, and this is the light in the third room. In this way you can connect the 3 rooms in parallel. Okay, so this is the first floor, connection to your first floor. Then if you want to again connect it to the second floor, what you will do, you will again tap out the wire from the in between. Okay, and connect this as, say the second floor has 4 rooms. Okay, so like this there will be 4 wirings, and this again goes back. So this is your connection to the second floor. Okay, so in this way the wirings are made, and then it is again taken back to the main switch. Okay, or the main power source. Okay, so this kind of connection, this kind of connection is actually called the ring system. This kind of connection is actually called the ring system. Okay. So I think the connection of the ring system is clear to you all. Okay. So in our housing, parallel system is being used and it is connected in a ring fashion. So this is the ring system of connection. So I think the concept of ring house wiring is clear to all of you. Okay, fine. Although I have drawn it very simply, the circuit in our house, in our real life application is not so simple. However, the concept is very much the same. Okay. Okay. Now let us quickly move on to the next topic, fuse. Okay. So we will be quickly moving on to the next topic, fuse. So see, in every electrical connection, I think you have noted down these concepts. If not, please pause the video, just move back a little and note down the figures. And if you have not understood it, just move through the video once again a little bit slowly. You will be able to understand it. Okay, fine. Now let us quickly see. Okay, so next topic is the safety devices. Safety devices. Okay, safety devices. So what are the safety devices? Now see, in every electrical connection there must be some safety devices to protect the electrical appliances. Now see, the electrical appliances that we use today are quite expensive, so you have to protect it. So from what danger do you want to protect your appliances? So there are mainly two problems that can happen, that can damage your appliance. Okay, so what are the main problems? Now see, first one is there can be a short circuit in your house. Okay, I'll be explaining these things step by step. Then there can be overloading. Okay, then there can be voltage fluctuations. So these are the mainly three situations in which you might want to protect your electrical appliances. Okay, so first of all, let us see what is short circuiting. See, say you have a live wire. I am explaining the concept of short circuit. Okay, say you have a live wire. Okay, then it is connected to an appliance. So this is a device. It may be an appliance. It has a certain resistance of its own. Okay, and then this is the return wire or the neutral wire. Okay, now see, we know that from Ohm's law, voltage equals to current into resistance, or I can say that I is equal to V by R. Okay, now see, connecting wires that are made up of copper or sometimes aluminum have very low resistance. Now what happens when I consider the resistance of this total circuit, this part of the circuit, it comprises of the resistance of these connecting wires as well as the resistance of the device. Fine. Now if you think of a situation where suddenly this live wire, this is the live wire just cuts off. Okay, just cuts off, and the insulation of the live wire breaks or has been damaged, and it just goes on and touches the neutral wire here. The insulation of the neutral wire may also have some broken by some means, and it touches this in this fashion. Okay, so what happens? Now suddenly the current will find a path which is having very less resistance. The current will suddenly become very high as because this resistance of the total circuit becomes very low, and as a result its high current starts flowing through this wire. Now every wire is designed to carry a certain maximum amount of current. It may be 2 ampere, 3 ampere, 5 ampere, accordingly it is designed. The wires which carry higher current are thicker in nature, that carry less current are bit thin in nature. So if it touches the live neutral wire by break of insulation, then suddenly high current starts flowing, and this high current becomes so large that the wire gets heated up. You know from the Joule's law of heating, I think you have remembered Joule's law of heating. The heat produced in the wire, connecting wires when current is flowing through it is I square RT. Now this current I becomes very high, obviously the heat generated will become very high, isn't it? The heat generated will become very high, and as a result there will be suddenly a fire, and this fire can cause a lot of damage. It may also result in a fire in your house. So this is one of the main problems that may cause damage to your appliance, as well as it can be a very dangerous situation for the entire house. Or say sometimes you have read in your newspapers or heard in the news that due to short circuiting there is a huge fire in some of the industries, factories. As a result, the whole factory has been burnt. So some news like this comes very often. So mainly due to that short circuiting, this is what actually happens in short circuiting condition. In this way, the current actually causes a large amount of heat due to the high value and causes fire to catch. So I think the concept of short circuiting is clear. Okay. Next, what is overloading? Say your main switch has been designed to allow certain amount of current. Now as all the devices in your house are connected in parallel, you know what happens, the total current in parallel connection adds up, isn't it? You have already read this in the current electricity chapter, or you have discussed this in current electricity. Now if you just connect too many appliances which have a very high power rating, isn't it, high power rating in the total circuit, then suddenly a large amount of current will be drawn from the power source, large amount of current, and that large amount of current can cause again overheating, and then it lead to the fire. So this is overloading condition. Okay. And voltage fluctuations, we have noticed this very often, that although nowadays this voltage fluctuation is not much, however in some places there are huge voltage fluctuations. Suddenly the voltage drops to very low value, 110 volt. In very short time the voltage becomes very high, say 250 or 280 volt instead of 230 volt. So in these conditions also a high current can flow to the device and it can damage. So these are the three situations in which your appliances can be damaged. So to prevent or protect your appliances from being damaged, or prevent say dangerous condition like fire in your house, we need some safety devices. Okay, so I think by now you have already understood why the safety devices are required. You have understood the various conditions under which the damages that you are using may be, the appliances that you are using that may be damages. Sorry for the mistake. Okay, so what are the safety devices that you mainly use in our household surfaces? Now see, in your syllabus there are mainly two safety devices that has been mentioned. One is the decade-old fuses that you use. Everybody knows that there are fuses in our houses. And the second safety device that we are talking about is the MCB. So this is a kind of modern safety device whose full form is miniature circuit breakers. Miniature circuit breakers. Okay. So these are the two forms of safety devices that are mainly in your syllabus that is to be discussed. Okay. So I think everybody has seen the fuses that are used in our homes, isn't it? If you see the main switch, if you get any chance to see the main switch within what is present within the main switch, if your guardian sometimes opens the main switch, if your father says your father means opens the main switch, and if you get a chance to see inside the main switch, please see that there are two large white colored something present inside the main switches. Those two actually are the fuses. Okay. So in main switch, actually what happens, there are two fuses that are being used. Okay. One is directly connected to the live wire, and the other one is directly connected to the neutral wire. Okay. So it's for extra protection purposes. Okay. But in rather other than the main switches, the fuses are mainly connected to the live wire. Okay. So just let us briefly discuss about the fuse. Okay. Then we will be discussing about the MCB or miniature circuit breakers. Okay. So what about the fuses? Okay. So fuse, if you say how can you define fuse? So fuse is actually a safety device. You can easily understand, safety device. Okay, has two porcelain holders. Okay, one is the socket and one is the plug. Okay, one is the socket and one is the plug. Okay, the third point you can say is that fuses have a fuse wire made up of an alloy of lead and tin. Okay, so remember, fuse wires are actually different from the connecting wires. Connecting wires are made up of pure copper or aluminium. There's a high conductivity. Okay, their melting points are also high. But fuse wire, there are certain features that a fuse wire should have. What are those features? I'll be just pointing it out. Just first write down these 3 points. That fuse is a safety device. These are two porcelain holders. A fuse wire made up of alloy of lead and tin. Okay. Now, in order, a fuse should have this alloy of lead and tin has very low melting point. Okay. As soon as a little amount of high current starts flowing through the fuse, remember this thing, as soon as all the fuses are rated for a certain value of current, maximum current. Now, as soon as a little amount of current which is slightly higher than the permissible rated amount, the fuse wire starts heating up, and as it is having a low melting point, it certainly melts and disconnects the circuit, it breaks the circuit. So in this way, whenever there is an overcurrent due to any kind of faulty situation in the circuit, the fuse wire disconnects the appliances connected to the power supply, and in order, thus it saves the appliances from being damaged, isn't it? Okay. So this is about fuse. Now, what happens? There are two things that I would like to discuss. What happens if you connect? If you connect, or if you use copper wire instead of this lead and tin alloy. Okay. What happens if you use copper wire? See, sometimes we do actually replace the fuse wire when it cuts by a copper wire, but it is not actually good. Fuse is for our safety purposes, so we should not be playing with our safety. That's a very big thing. So we will be always replacing our fuse wire when they are being damaged by fuse wire. Okay, of that same rating. Now, what happens if we use a copper wire? See, copper wires have very high conductivity. They have high melting point. So even if a high amount of current suddenly starts flowing through the circuit, the fuse wire will not get heat up and it will not melt, isn't it? So the very purpose of using the fuse, that is to protect your device, will not be achieved. The high current will flow easily through the fuse and it will reach your device, As a result, it will damage your device, isn't it? So what's the use of the fuse? Then just placing the fuse in the circuit has obviously no use. So that is why we should not use this copper wire. Okay, fine. Another thing is that fuse wires are always connected to live wires. Okay, so fuse are always connected to live wire. Remember this. Always connected to live wire. Okay, always connected to live wire. This is a very important point. Always connected to live wire. Fine. See, fuse are actually okay. I will be just drawing one diagram. Then it will be easier for you to understand. It will be easier for you to understand through the schematic or pictorial representation of the situation. See, you have a device, say any electrical appliance, a costly electrical appliance connected to the circuit. So this is the fuse that you are using, okay, and this is the live wire. So this is the power source, okay, this is the power source, and this is the neutral wire. Now see, what happens if you connect this fuse not to the live wire, rather to the neutral wire? What happens? Just see, just for demonstration I am showing what happens if you connect the fuse wire with the live wire. See what happens. Now see, this is a fuse, okay, it has been connected to this is the neutral wire, okay. Now if you connect the fuse to the neutral wire, what happens? And this is the live wire, okay. See, what does the light? This is an appliance, say a bulb or a light, LED light, okay, anything it may be. So see, if you connect the fuse to the neutral wire, what happens? The live wire carries the current first to the bulb, then the current, due to the current flow of the current, the bulb starts glowing, and then the current is returned back to the source via the neutral wire. So if the fuse is connected to the neutral wire, what happens? Suddenly, say due to a faulty condition, high current starts flowing in the circuit. What will happen? The high current will easily flow through the live wire, move out through the bulb, it will damage the bulb, and then it will pass to the neutral wire, and then the fuse will get rid of and melt and disconnect the circuit. So what is the use then? Already the appliance that I am trying to protect has been damaged. This is because the fuse wire has been connected to the neutral wire. So I think now it is very clear to you why you should be using the fuse not in this neutral wire, not in the connected to the neutral wire, rather it should be connected to the wire, to the live wire. Okay, so I think the concept is clear. Isn't it? Fine. So this is the main reason that a fuse wire should never be connected to the neutral wire, rather it must be connected to the live wire, okay, so that it can actually perform its function, the very function for which it has been incorporated into the circuit. Okay, so this is the concept of fuse. I think the concept is clear to all of you. Okay, fine. Now, so this is an old device. Fuse is not a very modern device. It's an old device and it has some drawbacks. What are the drawbacks? See, the fuse, although melts and disconnects the circuit, but it is not fast. It does not act very fast. It takes a little bit of time. And in places where your appliances are very costly and a little bit of, say you are using a laptop, a little bit of high current that can pass through the device will damage it. In those cases, fuse is not actually suitable. Okay, it takes time to melt and to disconnect the circuit. Also, there is another problem. Fuse, what happens? Fuse, it's actually if it gets the circuit breaks due to the melting of the fuse wire, you have to put up the circuit. You have to again open the fuse porcelain holder. You have to connect the fuse wire and then again put on the porcelain holder back into the circuit and then switch on the circuit. So it's a tedious work. It's a difficult work, isn't it? It's not possible for any person to do it. If the fuse wire just gets melted, you might have to call the electrician. So it's a difficult job. So for these reasons, with the evolution of the technology, the fuse has now become obsoleted, although fuse is still in use. It is not such that it has not been totally out of use. It is still in use, but the modern device that we use is the miniature circuit breaker in addition to fuse. Miniature circuit breaker. Okay. If in say 10 years or 20 years ago, all the safety devices were fuse, if you see in your house, now fuses are used but in very little quantity. Okay. Rather, you will see at places in your house that there are board where, say, a board like this will appear. Okay. There are lights like this, say 3, 4 or 5 lights like this, and there are small switches. Okay, there are small switches, there are small switch panels. Okay, say the switch is off and on, you can see there are small switch panels. Okay, 5 panels. Now this is the small LEDs, 5 LEDs and 5 switches. Okay, now what happens if suddenly due to any faulty conditions high current comes into the circuit, the switch automatically turns off. The switch automatically turns off. The mechanism, internal mechanism is such that the switch automatically turns off, and it rather protects your circuits. Now, it is easier. Why it is easier to operate? Because during any fault condition, if the switch goes off, you can repair the fault condition if you have understood where the fault has taken place, or you can rather disconnect that portion from the circuit and then again switch on the MCB. If you have not been able to identify the fault or where the problem is in the circuit, then, and if the problem still exists in the circuit, then the switch, if you switch it on, it will very instantly again switch off. Okay, so this is a very accurate device, and it takes very less time to operate. So it actually protects your device to a very good extent. It is rather more accurate than fuse. So with the evolution of technology, the internal mechanism is not in your syllabus. Just to know about the working, or just to know about this initial working, it has been included in the syllabus. So I think it is enough for you to know that it is a more accurate device than the fuse, and it is easier to use. Okay, so this is miniature circuit breaker or MCB. Okay, fine. So in this lecture we will be ending here. We have completed the safety devices. In the next lecture, we will be continuing from here. Okay, so I will be discussing about the earthing, 3-wire plug system, and the color coding of the wires that you use in your house. Okay, so till then, please do study well, stay safe. Okay, and to take care of yourself. So till then, thank you, goodbye. Okay.